Hello everyone. So today we will look at how to write our own transformers using uh, scikit-learn, and how we can use some of the built-in classes in scikit-learn, and how we can use in our favor. So let me first of all import the data from test and your train. So this is our data. Let us look at the columns. So here the point is that we have seen it previously. Some of the combinations, also for example ratio of some of these attributes or the labels, some of the attributes, for example, some of the columns may be interesting. For example, the price, the house value may have a good dependence on, for example, total rooms per household, for example. So in that case, we can say, for example, we want to find total rooms per household, for example. So how do we do it? First of all, say values equal to, these are our df dot values, second one, which is simply a 2D array of all our data. And then now if I take I can take 0 1 2 3, this is the third column, 3 4 5 6, right? So 3 by 6. So if I take the ratio of df, right, now values, I'm gonna take colon, I'm gonna index it 3, and then values, right, I'll take 3, right, 3 4 5 6, right. So we get this another array. So we took the ratio, and now for example I can do say I can add, right, I can import numpy as np, and I can use numpy dot we can concatenate this, right? I have my values and I'll take this ratio, right? So now we have concatenate the values, so we get those values at the end, we added the end. So this is what we want to accomplish. So let us write a class and a class method as a transform method so that we can perform this operation. So what we do, we say def as a class, for example I can call it as my transformer or something, right? And then I'm gonna def, right, init, I can say self, right? Let's keep it there at the moment. And then we need we say create a transform, and then just a self, and then let us add these, right? So this was, for example, rooms per household, right? So I can say room, see, something like that, and that one was this, right? So we calculated that, and now I say return rm, right? So we did that part. So now if let's consider if we for example do this my transform as a subclass of from sklearn dot base. If suppose BaseEstimator and TranformerMixin, these are two classes. If we do this as a subclass of my transformer, so if you write my transformer as a subclass of these two classes, for example if you look at TranformerMixin, if you look at it, gives already, if you get, we'll already get this fit transform. And let us have a look at the parameters, capital X and Y equal to none. So let us do that. For example mixin, and I have to do here x is the which is basically x is the values which already we have found, and y at the moment none. and we'll write definition of fit and return self. So if we have these two, it will automatically, because we are subclassing from TransformerMixin, will automatically get the fit underscore transform method. So now, so that is one thing. So now if so this is, so now another point is that if you look at df.columns again, some of the ratios or combination of attributes we may be, for example, doubtful. We may not be sure, oh, maybe it is not that interesting, maybe interesting, so we want to turn it off and on, so we can add it on this constructor call, a switch, for example, right? I can have a flag here, for example, in this case, say total rooms per bedrooms, for example, say room per bedroom, for example. I can keep it as a flag, and I can say here self dot room per bedroom equal to, for example, let us say, if you want, you can put a default is true, bedroom. So now so I added those parameters. So what is we have to do is, if we want if this self dot room per bed is true, if it is true, we want to also calculate that, right? So room, say per bedroom equal to, it was 3 and 4, right? Next to 3, we want to calculate this, and here we are not returning back room per house, right? We need to concatenate, right? numpy dot c underscore values, right? And room per house. That's what we are going to return, right? Yeah. So now here I calculated this, and I am going to return back what? numpy dot c and values, comma, and we'll also give it this back, definitely room per house, and we also give this guy room per bedroom so now I also we imported two bit. If we do this, the class that we wrote, my transformer, as a base estimator class, subclass of that, we also get, let us look at the base estimator. We also have a couple of methods. We can get parameters and set parameters, which are this guy. We can get this and look, and you can set it or get it, so let us also try to put the right base estimator class, and now we can, for example, create an instance. For example, we can test if it works, right? So I say my transformer, and let us keep the, for example, the default value true, and then I say transform, right? And so what do we want transform? We have to put, we are going to put the values, right? So see, it created both of the, it returned back both of the values, both of the transformation we performed, rooms per bedroom and rooms per household. And in case if you don't want, if we can put false here to the construction call, and then do, so at this moment we are only getting the rooms per household, right? And the base estimator class thing, like we can look at that, right? For example, if I equal to my transformer, maybe true or it doesn't matter, right? I can, so I dot get params, right? See, room per bedroom is already set pro, and so we already getting these methods because we did it as a subclass of the base estimator. So this, in this way, we have written our own transform, and since we did transformer mixing as a subclass of that, we have, and the base estimator, we get additional methods, and we defined a fit and a transform method, and the fit underscore transform is automatically available to us. So this is the idea, and so this is my journey of learning machine learning using Aurélien Géron's book, the scikit-learn book, and I am sharing things that I have learned. I believe this was easy to follow, and thank you very much for watching.